Okay, guys, we just finished um, graphing rational functions. We added, subtracted, multiplied, and divide, and simplified rational expressions. We solved rational equations. The last thing we want to do in this class with the word rational is a different form of what we're used to with square roots or cubed roots or fifth roots. Okay? I want to show you something. I think we know that the square root of 25 means what do I multiply by itself to get 25? That ends up being 5, right? Since 5 squared equals 25, the square root of 25 equals 5. Okay? They're inverses of each other. All right, the square root of 49 is 7 because 7 times 7 is 49. The square root of 81 is 9 because 9 times 9 is 81. Well, if I pull up my calculator and I take, 25 and raise it to the 1/2 power. 25 raised to the, parenthesis, 1/2 power. Right? I know that 25 squared is 25 times 25. 25 cubed is 25 times 25 times 25. 25 to the 1/2 power, guys, gives me 5. Just like square root of 25 gave me 5. 49 to the 1/2 power. You do have to be careful and put your 1/2 in parentheses. Okay, so it knows, the calculator knows to raise 49 to the 1/2 power. It gives me 7. Just like square root of 49 is 7. 81 to the 1/2 power gives me 9. Just like the square root of 81 gives me 9. Okay, this is a different form of what we've been used to calling radicals. Okay, or the square root form. Another form is to raise it to the 1/2 power. This is going to be 5. This is going to be 7. This is going to be 9. Okay, if it's cubed root of 8 is what do I multiply by itself 3 times to get 8? That would be 2, because 2 times 2 times 2, 2 cubed equals 8. So the cubed root of 8 equals 2. Well, when I take 8 to the 1/3, I'll show you on my calculator in case you're not convinced. 8 to the 1/3 power is also, oh my goodness, I can't get the 2. Again, it's just a new form that you may not have been aware of. 8 to the 1/3 is 2. Oh, goodness sakes. 2. Okay, 32, the fifth root of 32, since 2 times 2 times 2 times 2 times 2, 5 2's multiplied together gives me 32. Then that means the fifth root of 32 will give me 2. Okay, and I could write that as 32 to the 1/5. That will also give me 2. Okay, this is a new form. It's called rational exponent form. If I have the nth root of a to the m, another way of writing that is a to the m over n. Okay, this becomes the numerator. The root becomes the denominator in a rational exponent on a. So the cubed root of 5 squared, another way of writing that is 5 to the, this becomes the numerator, 2, this becomes the denominator, 2/3, 5 to the 2/3. Here, sometimes people forget that when there's nothing written, there's an understood 2 there. This is 7x cubed, the square root of that. Another way of writing that is 7x, in parentheses, to the 3/2 power. This is the numerator. The 2 is the denominator. 15xy to the negative 1/3. I'm going to combine a couple things here, okay? Since it said negative, the first thing I'm going to do is just rewrite this as 1 over 15xy to the positive 1/3. Okay, let's just, a negative exponent puts that into the denominator. And then writing it as a radical, anytime I have something to the 1/3 power, another way to express that is cubed root. Okay, we don't have to write to the 1. All right. Okay, so that's the last thing that we do with like rational, the word rational. Okay, there's rational exponent form that I just wanted to go over. Okay, hopefully you took those notes on the back of the notes I gave you. It wasn't much to write. I wanted you to explore these a little bit on your calculator, and then I wanted to show you this. Okay, so I have a quizzes that'll help you reinforce this before we do our very last lesson next week. Okay? All righty. I will see you guys in class. Good luck this week.